Okay, welcome to our third flipped lesson. This is on the metric system and conversions. Basically, the metric system is something you've talked about in the past. It's a base 10 system, whereas the English system is base whatever. Nobody really knows how many cups are in a pound, it's in a bushel. Base units then basically describe the type of measurement you are taking. So, for example, your base unit of grams is used for mass. From here, then, we use prefixes to describe how many grams we have or how many base units we have. So if we take a look at this picture here, the metric system, in order to measure volume, we're going to use the base unit of liters. Tool-wise, we'll use something like a graduated cylinder. Mass, we use the base unit of gram. Here we're going to use a balance scale. We're not really going to use a triple beam. Length, then, our base unit is meter, therefore we use a meter stick. So looking at the prefixes, you have your base unit. So again, this is grams, liters, meters, whatever. One bigger, one step up, but remember each step is worth 10, is deca. Okay, so a base unit, it requires 10 of them to equal 1 deca. If we go up another one, hecto, since it's 2 spots, it's 10 times 10. So it takes 100 base units to get to a hecto. From there, we go to kilo. After kilo, though, we need to skip a couple spots here and here, and we get to mega. So mega is 3 bigger than a kilo, which would make it 6 bigger than a base. Again, skip 2 more, and you get to giga. Okay? Notice these two are capitalized whenever these are lowercase. Going down, deci is 1 down, so it takes 10 decis to equal 1 base. Centis, it takes 100 of these to equal a base. And then milli meaning 1,000, takes 1,000 to equal a base. Again, jump down 2, and you get to micro, so it's 3 below a milli. Notice this is a funny looking M, that's the Greek letter mu. Go 2 more down here, and we get to nanometers, or nanos. Okay, go 2 more, and you get down there to pico. Hopefully you can see that. Pico you would only use if you're going to do something in college with chemistry or biology where you're using some special stuff. Nanos are often used for wavelengths, that kind of thing. For the most part, though, milli is about as far down as we go, in general chemistry at least. Alright, metric conversions then. Again, since we're base 10, we're just going to move the decimal the proper direction. So if we write out the metric system again, here's your base unit, so this is grams, liters, meters. Okay, you have deci, centi, milli, deca, hecta, or hecto, I'm sorry, and kilo. Alright? So if you had 45.67 grams, remember a gram is a base unit, how many centis is that? Okay, so we're starting here and we're going over here. So the first thing is, how many steps do we need? We don't count the one we're on. When you're counting steps in your house, you don't start on the floor and say 1. You say 1 when you step. So we have 1, 2 steps. Okay, so 2 steps, and we are going to move the direction of the decimal whichever way we move. So if we write it out like this, it's telling us our decimal needs to move this direction. Okay, 2 times. So if I do that, it goes 1, 2. Put my little decimal right there. So if we do that, we end up getting 4,567. So basically, look at where you're starting and where you're going, and how many steps it is how many times you're going to move the decimal. And if you write them out like this, then you just don't have to think about it. You just follow whichever way you got to go. So another example, we have kilometers and millimeters. So we know we have this many millimeters, 78,890, and we want to go to kilo, which is all the way over here. Okay, so if we take a look, how many steps is it going to take us? 1, 2, 3, 4, 5, 6. So 6 steps, and we're going to have to go in this direction. So our decimal is assumed to be right here. So we start moving it. 1, 2, 3, 4, 5, 6. Now I ran out of numbers, so I got to put a filler. Got to put a little 0 in there. Okay, so like I just explained it, how many steps per millimeter, kilometers, which direction? We're going to our left. So in the end, 0.07890. Okay, so we moved it 6 times to the left, and we had to fill in that placeholder. Okay, so again, if you write them out like this, or you remember it like this, however many steps and which direction, it's going to be real easy. Now the thing is, when you're done, you need to ask yourself, does it make sense? Does it make sense that the kilos, there's so little of them compared to the millis? A kilometer is somewhat like a mile. A millimeter is something like a 1/4 inch or less, actually, a lot less, more like a 1/16. Okay, so if you imagine taking a ruler and measuring 1/16 of an inch for a kilometer or for a mile, it would take a lot of those to equal 1 mile. Okay, so just kind of think about, does it make sense when you're all said and done? So again, how many milliliters are there in an ml? So since this is a capital, that tells us that we are using mega. Okay, let's see if I can erase this stuff here. There we go. Get rid of all this so we can see what we're doing. Okay, so we're starting at mega, and we're going to ml, little m, little l, which is milli. So the thing we got to remember, notice we have 2 spots right here. Okay, so I'm going to erase this as well. Let's start right here. Get up here. So we're starting right here. Put that. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it takes us 9 movements. Notice we're going this direction. So if I come down here, let me erase this. Oh, I messed up. Well, anyway, you get the idea. So I guess we'll have to stop there. I'm sorry. Let's see. Let me go back. Oh, there we go. So if you take a look, if we move this over 9 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to have to fill in a bunch of zeros to get that number. Okay, so I think most of you already knew how to do this, but I thought we better go over it. So now if you take a look in your Unit 1 packet, Section D is what you're going to want to look at. Also, keep in mind there is some scientific notation problems on there for you to do these conversions. So what you're going to want to do is take those scientific notations and write them in expanded form first, then move your decimals. So do those, and we'll talk about them tomorrow. All right.